Hello guys, Prime Concept once again. So you're welcome to this live session where we'll be unraveling a whole lot of concepts on optics. We have three things to actually handle. We're going to start with optics. I'll be summarizing a whole lot. And if at the end of the day we get a good number of people that are present in this live session, then it means we're going to have another session tomorrow to finish up because we have optics to deal with. And in optics, we have a whole lot of things to consider. Under optics, we're going to consider plane mirror. Remember, I'll be summarizing these things because it's a revision class. We'd look at plane mirror. We'd consider curved mirrors. We'd consider prisms. We'd consider, what's the name now? Lenses. We'd consider these things, telescope, compound microscope, and so on. So we have a lot to do. If we get a good number of people present in this live, then it means we're going to get tomorrow into thermal physics or waves, depending on what you would prefer. So do well to share this link, share it, tell your friends that Prime Concept is live. Tell them that we are live, we are starting. Share the link and begin to like the video, please. Like and then like the video so that the number of people that are present will be equivalent to the likes we have. How many people do we have?
10.
10.
11.
Share and keep sharing it, please. Tell your friends that we have started, and it's very important to be present in the class from the start so that you won't meet us halfway and you'll be confused. So do well to share. Tell your friends that we have started. Invite them. Meanwhile, don't forget to like. How many likes do we have?
11.
11. Thank you.
15%.
15. Those that are just joining, you're welcome. Like the video. If you are just joining, like the video. Share the link. Tell your friends. Prime Concept is live to unravel the concept behind optics. I would summarize it in such a way that you won't be scared of your exams again. So do we have up to 20 now? 15. I think I would start. So but do well to share the link so that others can join. Now, quickly, we're going to look at it in sequence, starting from plane mirrors. Now, let's quickly start. What is optics? When you talk about optics, what is optics? Remember, I'm going to be doing this revision and focusing on areas based on experience, areas you'll be expecting in your exam. So every single idea I would explain in this video is very important. So don't choose what to learn and what not to learn. I'll be teaching based on my research on how your exams used to be. So every definition I give is important. Now, what is optics? Optics is an aspect of physics that studies the propagation of light, how light travels, that is optics, or how light behaves around obstacles, that is optics. It's an aspect of physics that studies the travel or propagation of light. And you remember, optics can be divided into two parts. So you have two types of optics. Number one is ray optics. The exam can ask you which of the following is not a type of optics, so they can frame it in different way. So number one is ray optics, which you can also call geometrical optics. Then number two type of optics we have is what we know as physical optics. Now, what is ray optics? Ray optics is an aspect of optics that studies light using rays. Ray optics is an aspect of physics that studies light, but this time around it studies light using what you know as rays, right? That is ray optics, which is going to be the focus for this. Then physical optics will come later. Physical optics is a part of optics that studies the physical properties of light around matter, right? The properties of light around matter, such as diffraction and all these things. That is physical optics. Now, remember we said ray optics studies light using light ray. First, what is a ray? A ray is an imaginary line. A ray is an imaginary line that is drawn from an object to a point. That is a ray. It's an imaginary line, meaning that when you are looking at me, that you can see me now, it's just because rays are emanating from me. and that rays actually represent light, but you cannot see those lines, those rays, right? That is why we say rays are imaginary lines that emanate from an object. That is ray. Now, a group of ray, we can have more than one. If I have something like this is a ray, right? I have something like this, I have something like this. Each of them is a ray. But if you have so many of them like this collection has a special name which we know as what? Beam. So a collection of ray, a group of ray is referred to as beam, right? And then we have three types of ray. There are three types of ray you should learn in physics. Types of ray. So you have three types. Number one is parallel rays, or you can say parallel beam. So number one is parallel rays or beam. So please take note of these things. When you say parallel, it means that the lines or the rays are parallel to each other, such as this. It means that they are parallel to each other. That is number one. Number two type of ray we have is convergent ray. Number two is convergent ray. You know what this would mean? Rays that meet at a point, convergent ray. So they meet at a point. And how you differentiate this? Under exam, you have to be very careful. Don't just tick answers without watching the questions. So when you draw something like this, it can represent both convergent and divergent. But what makes this a convergent ray is that the arrows tell you that this whole thing are moving towards a particular point. So convergent rays are rays that meet at a point. The point where rays meet is known as what? That is the exam question. Type it if you know the answer. The point where rays meet or where they converge is known as what? Quickly, type it if you know the answer. How many persons do we have now?
22.
22, thank you. Keep sharing. I need us to be up to 50 this time around. I need us to be up to 50. So who has the answer? Anybody?
Not yet.
The point where rays meet, where they converge, this point is known as what? Focus. Is known as focus. You don't call it focus, you call it focal point. That is exam, these little things. So convergent rays are rays that meet at a point known as focus. Number three type of ray you have is divergent. Divergent ray. What are divergent ray? Divergent rays are rays that emanate from a point and spreads. These are rays that emanate from a point and spreads. So this divergent. What makes it divergent is the arrow. It's not just how it is. It's just the arrow. The arrow tells you that these things are spreading, starting from a fixed point. And the point where they appear to diverge from, this point is also known as what? Focus. You call it focus or you call it focal point. So these are the three types of rays that we have, right? Yes. Now, quickly, we want to get into reflection. We have, of course, we'll be picking them one after the other. We're going to start with reflection. Now, when you flash light, remember optics studies light. Whenever you flash light on a surface, three things can happen to that light. One of them is what we want to study. So when you incident light on a surface, the three things that can happen to that light is, one, that light can be reflected. So if I flash light on this board now, you will notice a reflection in your eyes. You won't be able to see clearly again because of reflection. Second thing that can happen to light that is incident on a surface is what? Absorption. So if you flash light on this thing, it is not all the light that you flash on this that would bounce back to you. Some of them would stay here and you can't see them again. So it means that this board has absorbed some of them. Then the third thing that can happen to light on the surface again is what? Transmission. Some of it can pass. Of course, it is not all materials that can transmit light. Just like a glass, if you have a glass window and you flash light on the glass window, some of the light will be transmitted, because if you stay behind the window, you would see the light. It means it has been transmitted. So the three things I've mentioned, Type them if you got what I've said. I mentioned 3 things that can happen. Type them if you really got them, because I don't want to repeat. If you got them, type them, the 3 things that can happen to light, and want to focus on one of them. Have they done that?
Not yet.
All right, how many persons are there now?
Oh, 29.
29. Please do well to like the video, share, invite your friends, tell them prime concept is life, unraveling the concept. Now, we want to consider reflection. What is reflection? Reflection is the bouncing back of light rays to the same medium from which it was incident. Reflection is the bouncing back of light ray, bouncing back of rays, not just light, of rays to the same medium from which it was incident. That is reflection, the bouncing back, which is very clear, of light to the same medium from which it was incident. Now, we have 2 types of reflection. There are 2 types of reflection that can always occur whenever you flash light on a surface. So number 1 type of reflection is what you call scattered reflection. If you don't want to call it scattered reflection, you call it diffused reflection. That is number 1 type of reflection. Scattered reflection occurs when light is incident on a rough surface. Scattered or diffused reflection occurs when light is incident on a rough surface. Under this condition, the reflected ray intersect each other. That is your scattered reflection. So this is what you have. Say this is our rough surface, and you incident parallel rays on this rough surface like this. These are parallel rays. Remember, any ray that is going in is your incident ray. Anyone coming out is your reflected ray. And when you incident parallel rays, because this is a rough surface, when they are coming out, they will begin to cross each other like this. So you would see this one like this. You would see this one. So you see that the rays, the reflected rays, they cross each other. So this kind of reflection is what you call scattered or diffused reflection, and they occur on a rough surface. Now, number 2 is what you know as regular reflection. Regular reflection. Now, what is a regular reflection? Of course, you understand it now. Regular reflection is reflection that occurs on smooth surfaces, right? For regular reflection, the reflected rays are parallel to each other. For regular reflection, the reflected rays are parallel to each other. So it occurs on smooth surface. So if I incident rays like this, these are my incidents. When it hits my surface, they would come out parallel to each other like this. They will come out parallel. So these are your reflected rays. So this type of reflection is what you call regular reflection. So I hope you're still following me. Now, if you are still following me, we want to quickly mention the laws of reflection. The laws of reflection. You have 2 laws of reflection. Laws of reflection. Laws of reflection. There are 2 laws of reflection. Number 1 says that the incident angle equals the angle of reflection. Number 1 says that the incident angle when light is incident on a smooth surface equals the angle of reflection. So that is just the first law. In a mathematical form, you can just say that I is equal to what? R, capital R is used for reflected angle of reflection. Remember, reflection and refraction are not the same. We're talking of reflection. So angle of incident is equal to angle of reflection. but angle of incidence is never equal to angle of refraction. So take note of that. So this is the first law. Now say I have a surface like this, and then this is my incident ray. This is my incident ray, and this is my angle of incidence. Then this is my reflected ray. This place is my angle of reflection. So what this is just saying is that these two angles would always be equal. That is what it is saying. Now watch. This angle that the incident ray makes with the surface, I'll call it theta, which is usually what it is called. Now theta is known as angle of glance. Theta is called angle of glance, or you can just say glancing angle. Theta is called angle of glance or glancing angle. I hope you are following me now, because I'll give you a quick question, then you drop the answer. Now watch. I can still produce this diagram. I can still produce this. If I produce this angle that is measured from the continuation of the incident ray to the reflected ray, this angle is known as angle of deviation. Deviation. It's called angle of deviation. I hope this is clear to you. So I'll give you a quick question. Light is incident on a smooth surface at a glancing angle of 20 degrees. Find number one, find R, which you know. Number two, find I. Number three, find the angle of deviation. So I'm waiting for you to solve this, and then I'll move on so I can be sure you're following. How many persons are there now?
28.
28. I need you to be up to 50 minimum, right? And how many likes do we have?
20.
20. Some of you have not liked the video, and it is not good. It's not fair. You're following this live video that is benefiting you. Just click the like button. And if you are yet to subscribe, hit the subscribe button, right? This is your only little way of showing your support, right? So please hit the subscribe button, hit the like button, please. I want to see more subscriptions by the time we are done. Invite your friends. I'm waiting for you to produce the answer. Any answer?
Not yet.
Wow. Remember the exam, for those of you in UNN, the exam is on Monday and on Tuesday. So it means at this point, you should be ready to produce answers very fast. No answer would solve, right?
Yeah.
All right. Now, the question says light is incident on a smooth, this is on, right? Is incident on a smooth surface at a glancing angle of 20 degrees. Find the angle of reflection, find the angle of incidence, and then find the angle of deviation. So let's start. First of all, I will get this. I was supposed to ask this first. Now, you know that the relationship between glancing, this is glancing, the relationship between glancing and incident is 90 degrees. So it is constant. You should know that theta, which is glancing angle, plus incident angle would always add up to 90 degrees. That is to say, exam can ask you which of the following is true for glancing angle and incident angle. Option A, they are complementary. Option B, they are supplementary. Option C, they add up to 360. Option D, they add up to 270. Which of them is true? Drop the answer in the comment section. So you can see a whole lot of questions are coming out. A little thing we are doing. So which of them is correct? Of course, they are complementary. Complementary angles are angles that adds up to 90 degrees. Those are complementary angles. Now, so we have that theta plus I is 90, and we know that theta is 20. So I would say 20 plus I equals 90 degrees, and then I becomes 90 minus 20, which is what now? 70 degrees. So incident is 70. So nobody got it up till now. Nobody is not good. Now, this is the first question, or this is the second anyway. Now, the first one, let's solve it. Now, we know from the law of reflection that angle of incident equals angle of reflection. So if incident is 70, reflection is 70. So R equals I, and since I is 70, it means R is also what? 70. So we've gotten that. The next is the angle of deviation. So you would see from that diagram, this is how the diagram is. This is how the diagram is. So this angle, this is deviation angle. This is R. You can solve this in so many ways, and this is I. So you would see that this is a straight line. Actually, this is a straight line. So that the addition of all these angles would give us what? 180. So I can say delta, my deviation, plus R plus I should be equal to 180. So that delta plus 70 for R, 70 for I is 180. So if I solve this, delta is 180 minus 120, right? 140 minus 140, which is what? 40 degrees. So nobody got it, right?
Yes.
It's quite unfortunate. So delta is 180 minus 140, which is 40 degrees. So that is my angle of deviation, 40 degrees. So do well to screenshot this so that we can move on. Can I move on? If you want me to move on, say yes fast, because it seems like the group that are following today, they don't want to respond, they don't chat, they don't want to say anything. What is happening? So if you want me to move on, say yes. Move on, move on. All right, I think I would move on. It seems like you are not interacting, so that I will know what to do at a particular time. So I should just be teaching straight without asking you any question. I hope that is good. That would be best. So this is the first law. Remember, we're looking at laws of reflection, and we said that the first law is that R is equal to I. And the second law says the angle, the incident ray, the reflected ray, and the normal at the point of incident lie on the same plane. The incident ray, the reflected ray, and the normal at the point of incidence lie on the same plane. That is the second law. I don't know, there's no point writing it. Let me just write. The incident ray, the reflected ray, and the normal at the point of incidence lie on the same the second law of reflection, right? Now quickly, we want to look at a plane mirror. Plane mirror. I'm gradually moving. What is a plane mirror? Of course, you know that everybody has seen a plane mirror. That mirror you use at home to check yourself is a plane mirror. So a plane mirror is a plain glass in which one side of it is coated. That is a plane mirror. A plain glass in which one part of it is what? Coated. And this is how we denote plane mirror in physics. We always use a dash at the back. So wherever you see dash, that part means that this is the back of the mirror. This is the back, and this is the front of the mirror. The shaded part is the back, the other side is the front. So that is a plane mirror, right? Now, we want to quickly point out the properties of a plane mirror that you need to know. What are the properties of a plane mirror? Properties. Now, can I allow you to mention? We have so many, which I believe that everybody, both those in GS1 would know it. So can you just type the one you can remember in the session? Give me one property you can remember while I mention, or give me one you can remember. Now, one property we should know for plane mirror is that the object distance is equal to the image distance. The object distance is equal to the image distance. So that is one property we should know. Object distance equals image distance. This is one property to know. Number two property to know is that object is same height as the image. The height of the object is the same as the height of image. Height of object is same as height of image. So this another property to know. Number three property. Number three is that image is laterally inverted. Image is laterally inverted. You know what this one means? If you stay in front of your mirror and you place your hand like this in front of your mirror, it will face you this way, right? That is lateral inversion. So the image is laterally inverted. Number four, the image is virtual. Image is virtual. So the image of a plane mirror is always virtual. It is not real, right? What is a virtual image? A virtual image is an image that cannot be caught on a screen. If you did experiment under curved mirrors, you notice you usually place a screen to catch the image on the screen. Now, if the image is virtual, you won't see anything on the screen, but if it is real, you would see it formed on a screen. So a virtual image is image that cannot be caught on a screen, or you can say a virtual image is image that is formed at the back of the mirror. So you can still say that. Now, number five and the last I'm mentioning, the image is erect. Image is erect, or you can say image is what? Upright. Image is erect, or you can say image is upright. That will bring me to number six, which is just a point to note. The magnification of a plane mirror is 1. Always, magnification of a plane mirror is always what? 1. Is unity. Is equal to 1. Now let me give you this problem if you are following me. If you are following me, say hi, say hi. Let me know that I'm still working with people. Do I still have people there? Say move on, move on. I want you to interact with me. Do I still have people there?
Yeah, but they are not responding.
And is network affecting you? Just mention if network is affecting, please, so that I will know what I'm doing. So please respond. Is network disturbing you, or you have chosen not to answer prime concepts? Which one? So answer this question if you are following me. Let me write it. No response yet, right?
They are responding.
They say no network issue.
They are responding. Just they are writing hi. Move on.
Okay. A man 2 meter 50 cm tall stands a distance of 3 meters in front of a large vertical plane mirror. Determine the size of the man formed by the mirror. This is one part of it. The second part of it says how far from the man is the image. So quickly, I want you to solve this. I'm giving you 30 seconds. Solve this so that we can do together. Remember, we're preparing for exam, and you should be watching this video with your pen and your paper. You shouldn't be watching this video and be eating or be doing something else. You should be watching it with your pen, paper, and your calculator. Calculator will be allowed in your exam hall. So please try to participate like you did in electromagnetism, right? So try to participate. Solve the question.
Okay. Nkemjika said.
Nkemjika, thank you. First person to produce answer. I love that.
2.5 meter and 6 meter.
2.5 meter
and 6 meter.
And 6 meter.
Enoch agreed with her.
Okay.
Then Anthony says 2.5.
Anthony, 2.5
meter for the size of the man, and the height is 3 meter.
3 meter for the second. Okay.
Then Charles says 2.5 meter. The only answer that he gave. Okay. Then Chisom said 2.5 meter and 6 meter.
Okay. All right. I think we can move on. I love the fact that you are responding now. So let's solve together. Remember the properties of plane mirror. When you see questions under plane mirror, you don't have to waste your time. And this is what we have. This is a plane mirror. And they said a man 2 meter 50 cm tall. So this is talking about the height of the man. The man represents the object. So the height of the object is 2 meters 50 cm. That's the height of the man. Now watch, you can combine, divide this, then combine. Remember 50 centimeter. If you want to change 50 cm to meters, what do? You divide it by 100. So 50 divided by 100 is 0.5. 0.5 plus 2 is going to give us 2.5 meters. So it means that the height of the object, which is the height of the man, is 2.5. Now they said the man stands a distance of 3 meters in front of the mirror. Now, the distance of the man, which is the object, remember the man is our object. So the object distance is 3 meters in front of the mirror. And the first question says, determine the size of the man. Size simply means height. Don't forget. Whenever you hear size, it means height. Determine the size of the man formed by the mirror. So it means they want us to get the height of the image. For plane mirrors, height of object equals height of image. We have said it. So it means that if the height of the object is 2 meters 50 centimeters or 2.5 meters, it means that the height of the image is the same thing. So the first question is 2.5, or you can say 2 meters 50 cm. Anyone you see in your option is correct. So it means that this person got this other person got it, this person also got it. Now the second part of the question says, how far from the man is the image? Now watch, this is our young man, and this young man, which is the object, is a distance of 3 meters from the mirror. Remember, object distance is the distance of the object from the mirror. Now, the image of this man is formed somewhere around there. So it means, from what we know for plane mirrors, object distance and image distance are the same. So if from here to here is 3 meters, from here to here should also be 3 meters, right? This is object and this is image. Now, this question says, how far from the man is the image? They want us to get the distance from this place to this place, which you can see is a total of what? The total of 3 plus 3, which is 6 meters. So it means this first person got it, right? He got it correctly. So that is what you should know for plane mirror. Moving on, I want to rub the question. So moving on, I have to move the next thing, which is rotation of plane mirror. Rotation of plane mirror. Rotation of plane mirror. Now, when a plane mirror is rotated through an angle of theta, then the angle of reflection is rotated or turned through twice that angle. Now, say you have your plane mirror like this. This is your normal. This is your plane mirror. This is your incident ray, right? And this is your reflected ray. If you decide to rotate this plane mirror to now be like this is now your plane mirror, so that you rotate it through an angle of theta. What they are saying is that the reflected angle, the new reflected angle, is going to be 2 theta. So take note of that. I don't want to do any derivation. The concept says if a plane mirror is turned or rotated through an angle of theta, then the reflected angle would shift through 2 times that angle. So let me quickly ask you, if a plane mirror is rotated through an angle of 45 degrees, what will be the angle of the new angle of rotation for the reflection? Tell me. A plane mirror is rotated through an angle of 45 degrees. What would be the angle of reflection, the new angle of reflection? What will it be? Type it quickly. I'm waiting for you this time around. Type it before I move on, so that I can be sure you're following me. Type it. Anybody?
Not yet.
I'm waiting.
I think you should pause the video. Let's start again.
Yeah.
Wow. It's bro.
Okay, please, let's quickly reset the video.